In this video, we're going to solve some problems on rate of chemical reactions. The first problem is, in a reaction, the concentration of a reactant A changes from 0.200 mole per liter to 0.150 mole per liter in 10 minutes. What is the average rate of reaction during this interval? So we know rate is equal to change in concentration divided by time taken as we are measuring the rate in terms of reactant. So the average rate will be negative sign change in concentration of A divided by change in time. So final concentration is 0.150 negative 0.200 divided by 10. So after calculating, the answer will come out to be 0.005 mole per liter per minute. This is our answer. Our next problem is decomposition of dinitrogen pentoxide is expressed by the equation N2O5 gives us 2 NO2 plus half O2. If during a certain time interval, the rate of decomposition of N2O5 is 1.8 into 10 inverse 3 mole per liter per minute, what will be the rates of formation of nitrogen dioxide and oxygen during the same interval? The rate expression for this reaction will be negative sign d of N25 divided by dt is equal to plus 1 by 2 t NO2 upon dt is equal to plus 1 by half dO2 upon dt. So the rate of decomposition of N2O5 is given negative sign dn2o5 upon dt is equal to 1.8 into 10 power minus 3 mole per liter per minute. So the rate of formation of nitrogen dioxide will be 2 multiplied by negative sign d of n25 divided by dt is equal 2 into 1.8 10 inverse 3. That means 3.6 into 10 power minus 3 mole per liter per minute. And the formation of oxygen will be dO2 upon dt is equal to half multiplied by negative sign dN2O5 upon dt. So answer will come 0.9 multiplied by 10 power minus 3 mole per liter per minute. The next problem is for each of the following reactions, express the given rate of change of concentration of the reactant or product in terms of the rate of change of concentration of other reactants or products in that reaction. So in the first reactions, we have to write the rate expression. So we're going to the next page. Rate expression for the first reaction is so the rate for this reaction will be negative sign d of H2O2 upon dt, negative sign 1 by 2 T of H plus upon dt, negative 1 by 3 T of I minus upon dt, positive sign D of I3 negative upon dt equal to positive 1 by 2 D of H2O upon dt. So we have to find out negative sign di minus upon dt and negative sign dh plus upon dt. So if we multiply every term in this rate expression by 3, then we will find negative sign of di minus upon dt. So negative sign di minus dt will be minus 3 dH2O2 upon dt minus 3 by 2 dH plus upon dt 3 multiplied by d of I3 negative upon dt is equal to 3 upon 2 d of H2O upon dt. And if we find out negative sign dH plus upon dt, we have to multiply every term in this rate expression by 2 because here is 2. So here is our problem A. Our problem B is this reaction. So we have to write the rate expression for this reaction first. So the rate expression for this reaction will be negative 1 by 16 d of h plus dt negative 1 by 2 d of mn over negative upon dt negative 1 by 10 d of I negative upon dt plus 1 by 2 d of mn2 positive upon dt or plus 1 by 8 d of h2 upon dt or plus 1 by 5 d of I2 upon dt. So we have to find out negative sign of d of mn for negative upon dt. So we have to multiply each of these term in this rate expression by 2. So negative sign d of mn for negative upon dt will be minus 1 by 8 d of h plus divided by dt minus 1 by 5 d of I minus upon dt equal to plus d of mn to plus upon dt equal to plus 1 by 4 d of h2o upon dt equal to positive sign 2 by 5 d of I2 upon dt. So let's go to the Third question. So the reaction between ammonia and oxygen gives us nitrogen dioxide and water. So the rate expression for this reaction. Okay, so we have to find out negative sign T of ammonia dt. So we have to multiply each of this term in this rate expression by 4. So this is our answer for this question. So here are example 4. The following reaction was carried out in water. Chlorine plus 2I negative gives us iodine plus 2Cl negative. The initial concentration of I negative was 0.25 mole per liter, and the concentration after 10 minutes 0.23 mole per liter. Calculate the rate of disappearance of I negative and appearance of iodine for this reaction. So the rate expression for this reaction is negative sign d of Cl2 upon dt is equal to negative 1 by 2 d of I minus upon dt, while positive d of I2 upon dt is equal to 1 by 2 d of Cl minus upon dt. So negative sign of di minus upon dt is equal to, here final concentration is 0.23 minus initial concentration 0.25, and it has taken 10 minutes, but we have to keep the rate of disappearance of negative positive, so we have to give a negative sign before it. So the final answer will be 0.002 mole per liter per minute. And we have to calculate the appearance of iodine. So the appearance of iodine di2 upon dt is equal to half multiplied by negative sign di negative upon dt. Means half multiplied by 0.002. So the answer will come 10 power minus 3 mole per liter per minute. So our next problem is about the reaction between dichromate ion and nitrous acid in an acidic medium. The rate of disappearance of dichromate ion is found to be 2.4 into 10 power minus 4 mole per liter per second during a measured time interval. Find the rate of disappearance of nitrous acid and the rate of appearance of chromium 3 positive ion during this time interval. So the rate expression for these reactions. So the rate of disappearance of dichromate is given. So we can write the rate of disappearance of nitrous acid equal to 3 multiplied by rate of disappearance of dichromate ion. So the answer will come out to be 7.2 into 10 power minus 4 mole per liter per second. And the rate of appearance of chromium 3 positive is equal to 2 multiplied by rate of disappearance of dichromate. So this is our answer for this question. So here is our next question. Ammonia and oxygen react at higher temperature, as ammonia and oxygen gives us nitric oxide plus water. In an experiment, the concentration of nitric oxide increases by 1.08 into 10 power minus 2 mole per liter in 3 seconds. Calculate rate of reaction, rate of disappearance of ammonia, and rate of formation of water. So at first, we have to write the rate expression for this reaction. So at first, we have to find out the rate of reaction. Rate will be plus 1 by 4 dNO upon dt. So 1 by 4 multiplied by the change in concentration of nitric oxide is 1.8. 1.08 into 10 power minus 2, and the time taken is 3 seconds. So our rate will come out to be 9 multiplied by 10 inverse 4 mole per liter per second. So we have found out the rate of reaction. The second one is rate of disappearance of ammonia. So negative sign d of NH3 on dt is equal to 4 multiplied by rate of reaction. And the rate of formation of water is equal to 6 multiplied by rate. That means 54 into 10 inverse 4 mole per liter per second. So this is our answer for this question. So our next problem is the rate of reaction is expressed in different ways as follows. Plus 1 by 2 dc upon dt is equal to minus 1 by 3 d capital D upon dt is equal to plus 1 by 4 d capital A upon dt is equal to minus d capital B by dt. The reaction is, so by seeing the rate expression, we can tell that C and A are our products and B and D are our reactors. Because there is plus sign in the rate expression of C and A and the negative sign in the rate expression of B and D. So our reaction will come out to be the second one. Capital B plus 3D gives you 4A plus 2C. The next question is, in the reaction, A plus 2B gives you 6C plus 2D if the initial rate at T is equal to 0 is 2.6 into 10 power minus 2 molarity per second. What will be the value of rate of disappearance of B at T is equal to 0? So we can write the rate in terms of B negative sign 1 by 2 dB upon dt. So the rate of disappearance of B will be multiplied by rate. So the answer will come out to be 5.2 into 10 power minus 2 molarity per second. So answer will be option number 3. Our next problem is further reaction. 2A gives you B plus 3C. If negative sign dA upon dt is equal to K1 into concentration of A power 2, dB by dt is equal to K2 into concentration of A power 2, and dC upon dt is equal to K3 into concentration of A power 2. The correct relation between K1, K2 and K3s. So we can write rate expression for this reaction. Negative sign 1 by 2 dA upon dt is equal to minus, so plus, because B's are correct, dP upon dt is equal to plus 1 by 3 dC upon dt. So we can write half dot K1 concentration at 2 is equal to K2 concentration of A power 2 is equal to 1/3 dot A3 concentration power 2. So if we cancel out concentration of A power 2 for each of these terms, we find out K1 by 2 is equal to K2 is equal to K3 upon 3. So the relation between K1, K2 and K3 is the option number D. So here is our problems on rate of chemical reactions, and I hope uh, you have understood the concepts very well, and thanks for watching the video, and don't forget to like, comment and subscribe.